Hello, welcome to Flipped. Today we're on a chapter of energy from chemicals. A chemical reaction is defined as follow. It's basically when we take in energy to break old bonds in reactants, and when we give out energy to form new bonds in products. So what do I mean? For example, I have a molecule of A here reacting with a molecule of B. Okay, to give us, basically they swap their atoms around to give us two, okay, shouldn't use this white, to give us two molecules of AB. Okay, what do I mean? For example, AA is connected by this blue bond here. BB, the atoms BB are connected by a yellow bond. And AB is connected by a purple bond. Okay, so this one is the same. So when we say this chemical, these two molecules have undergone a chemical reaction, basically what we are saying is that we are breaking the O bonds here. Okay, these are called O bonds because they are from the reactants. Okay, AA. So these are all reactants. Okay, before the arrow here is called reactant, and after the arrow is called a product. Okay, this is just a recap. So when we say it's a chemical reaction, we are breaking the O bonds, the blue one in this case and the yellow one here, in the reactants, and to give us new bonds, okay, to form new bonds in products, which are these two purple or pink bonds here. Okay, this is basically what an idea of chemical reaction is. We break O bonds, we form new bonds, and then we can calculate the relative heat given off in this reaction. And that's where we talk about the heat of reaction. Basically, this is the enthalpy change of reaction called change in H. This triangle is a universal symbol for change. Okay, change in H. In this case, H means heat. And this measures the amount of heat given off or taken in a reaction. The units are joules, J, or kilojoules, kJ. So this one, okay, this is nothing, the conversion of this is not something entirely new. Remember, we have this thing called grams, and we have this thing called kilograms. So from grams to kilograms, we divide by 1000. From kilograms to grams, we multiply by 1000. So it's the same thing for joules to kilojoules and kilojoules to joules, etc. So it's the same thing as what we have learned before. The formula is as such: change in H equals to energy of bonds broken. In the case of AA and BB, is the blue and the yellow. Okay, that's the bonds broken, minus away the energy of bonds formed, which are two pink bonds. Okay, this one we'll talk about. We have an example later to talk about this. So when we calculate this change in H, we have a value. Okay, if the thing is positive, it's called endothermic. Endothermic means heat is absorbed from the surrounding, and if it's negative value, it's called exothermic. Okay, heat is being released into surrounding. How do I remember? Negative, okay, is released into surrounding. Why? Because the word of called exo. So exo sounds sounds like the word exhaust pipe, right, in a car. So exhaust pipe gives out something. Okay, gives out the gases after the reaction in the car engine, for example. So this one is called release into the surrounding. Okay, so exo is release into the surrounding. It's a negative value. So when we talk about the positive and negative value, very important. Positive has to be denoted with a positive sign. So if it's 1000 kilojoules, it's positive 1000 kilojoules, or it can be minus 1000 kilojoules. So this goes against what we are used to in mathematics, right? Because when we say 1 plus 1 gives us 2, all right? This is primary school, but in this chapter it's a bit special. We cannot write 2. We have to write plus 2. Okay, this just to denote the positive and negative sign in front, because in this chapter it's very important, okay, to show the positive and negative sign. Okay, whereas for minus 1 plus minus 3, okay, gives us minus 4. Okay, so it's minus is the same, because minus we always had to denote the negative sign, but positive is a bit special in the case that usually we don't denote this positive sign, but in this chapter we have to denote the positive sign.